Enzymes are among the most important of all biological molecules. I always joke with students that if you're unsure of an answer to a question on a biology exam, if you write something about enzymes, you're probably going to get some partial marks for that because that's how important enzymes are. So, what is an enzyme? An enzyme catalyzes or speeds up a chemical reaction without being consumed by that reaction. And one of my favourite examples for explaining this is the reaction in which hydrogen peroxide is converted to oxygen. You may be familiar with hydrogen peroxide as a product that is used by hairdressers to bleach hair. However, it is also a natural byproduct of cellular respiration. Hydrogen peroxide is harmful to living things because it is a strong oxidizer which can cause damage to cells. Therefore, cells have to have a way of removing hydrogen peroxide, and they do this by converting it into water and oxygen gas. Because you are breaking down hydrogen peroxide into less complex products, it is a catabolic reaction and as such releases heat as the result of the reaction. To demonstrate this reaction, you can simply pour hydrogen peroxide into a beaker. If you watch hydrogen peroxide in the beaker carefully, you might think that nothing is happening, but it is. The hydrogen peroxide is breaking down or decomposing into water and oxygen. It is just that the rate of this reaction is extremely slow. And this is why they sell hydrogen peroxide in brown bottles, to minimize exposure to light, which increases the rate of this natural decomposition. If cells relied on this natural rate of decomposition, then hydrogen peroxide would not be removed fast enough and they would become damaged or even killed. Instead, cells use an enzyme called catalase to speed up the rate of this reaction and remove the hydrogen peroxide. Catalase is produced by nearly all living organisms, including yeast. If you make up a solution of baker's yeast and add it to the hydrogen peroxide, what do you think might happen? Well, if you're clever, you'll realize that the catalase in the baker's yeast will catalyze or speed up the rate of decomposition of hydrogen peroxide. This means that oxygen will be produced at a faster rate, and you'll see it bubble rapidly and froth. Catalase is found in several organs and tissues, including the liver, whose job it is to speed up the breakdown of hydrogen peroxide. I mentioned earlier that enzymes are biological molecules that speed up the rate of reaction without being consumed. This is because enzymes are not destroyed or altered by the reactions they catalyze. They can be used again. So for example, there is the same number of catalase enzymes at the beginning and the end of the decomposition of hydrogen peroxide. Therefore, if you added more hydrogen peroxide, then the catalase enzymes would decompose it into oxygen and water. And this is really important as enzymes need to be readily available to catalyze the thousands of biochemical processes that occur in cells. Now, there are other molecules that can catalyze the decomposition of hydrogen peroxide. For example, potassium iodide. However, potassium iodide is not considered an enzyme, whereas catalase is. So what's the difference? Well, enzymes are biological molecules. Potassium iodide is not a biological molecule, and therefore it is not an enzyme, but it is a catalyst. In other words, all enzymes are catalysts, but not all catalysts are enzymes.